All right, today we are cracking the code on algebraic expressions. We're going to learn how to read them, write them, and solve them. Think of it like learning a new language, one that turns a confusing jumble of letters and numbers into a powerful tool you can actually use. Let's dive right in.
You know that moment in math class when all of a sudden letters just invade the problems? Yeah. If you've ever stared at a page and wondered why X and Y decided to crash the numbers party, you are definitely in the right place. We are going to make sense of it all.
So, here's our game plan. First, we'll break down the code, learn the basic vocabulary. Then, we'll jump into combining terms using addition and its tricky sibling subtraction. And finally, we'll get to the big payoff, using all these skills to find one single final answer.
Okay, first things first, we have to start with the fundamentals. Before we can start doing operations, we need to know what all the little pieces are called and what their job is. It's just like learning a language. You've got to know the words before you can form a sentence, right?
First, up is the variable. This is probably the most famous part of algebra. It's just a letter, like X, Y, or whatever, that's acting as a placeholder for a number we don't know yet. And it's called a variable because its value can vary depending on the problem.
Spotting them is pretty easy. So in 5x plus 7, the variable is, of course, x. In the next one, 2a minus 3b plus 1, we actually have two of them, a and b. And in that last one, the variable is p. See? It's just the letter that stands in for that mystery number.
Next, we've got the constant. And a constant is pretty much the exact opposite of a variable. It's just a plain old number. It's reliable, it's dependable, its value is, constant. It never, ever changes.
So for example, in x plus 8, the constant is just 8. Now, here's something really important to remember. The sign always stays with the number. So in 3y minus 5, the constant is actually negative 5. And yeah, constants can be fractions too, like the 1/2 you see here.
All right, let's talk about terms. Think of these as the individual building blocks of the expression. They're the chunks that are separated from each other by a plus or a minus sign.
Let's look at this in action. The expression 3x plus 7 has two terms. The 3x is a term, and the 7 is a term. The expression below that, 5a minus 2b plus 10, has three terms, 5a, minus 2b, and 10. And again, see how that minus sign sticks with the 2b? That's key.
And our last vocabulary word is the coefficient. That's just the number that's right out in front of a variable, the one it's being multiplied by. In 5x, the coefficient is 5. And here's a little pro tip. If you ever see a variable just sitting by itself like x, there's an invisible 1 in front of it. So its coefficient is 1.
Okay, think of this chart as your official algebra to English translation dictionary. It helps us turn word problems into math we can actually solve. But be careful, watch out for tricky phrases like less than. Notice how 7 less than y actually becomes y minus 7? The order gets flipped. That is a super common trap, so keep an eye out for it.
All right, we've got the vocabulary down. Now it's time to start actually building some sentences. Let's start with the easy one, adding expressions together.
The most important rule here is that you can only combine like terms. That just means terms that have the exact same variable part. It's like you can add apples and apples, but you can't add apples and oranges. So here, we group the x's together. 3x plus 5x gives us 8x, and then we group the constants together. 2 plus 7 is 9. And that's our final answer, 8x plus 9.
Okay, get ready. Subtraction looks a lot like addition, but it has one tiny but very important twist. There's a rule here that if you forget it, it'll get you into trouble almost every time. But don't worry, we are going to nail it down right now.
This right here, this is the golden rule. If you remember one thing from this whole section, make it this. When you subtract an entire expression in parentheses, you have to flip the sign of every single term inside those parentheses. Once you do that, it just becomes an addition problem.
Now there are two great ways to handle this, the horizontal method and the vertical method. They both get you to the exact same answer, so you can just pick whichever one feels better to you. We'll walk through the same problem using both so you can see how they work.
So with the horizontal method, your first move is to distribute that negative sign. The negative 2x plus 3 becomes negative 2x minus 3. See how the signs of both terms inside the parentheses got flipped? That's the crucial step. After that, it's business as usual. We group our like terms and combine them to get our answer, 3x plus 4. And here's the vertical method. You start by stacking the like terms on top of each other. Then,
And this is the magic move. You go through the entire bottom row and you flip every single sign. The 2x becomes negative 2x, the plus 3 becomes negative 3. Then you just add straight down the columns. And look at that, we get the same answer, 3x plus 4.
And now, the payoff. Why do we even do all this? What's the point? Well, this is it. It's so we can get a real concrete number as an answer. This is where we plug in some values for our variables and find out what the expression is actually worth.
Let's tackle this problem together. We need to evaluate 2x plus 3y minus 1. And they've told us that for this problem, x is negative 1 and y is 4. So let's plug them in and solve it.
The very first thing we do is substitution. We carefully go through and replace every x with negative 1 and every y with 4. Now, I cannot stress this enough. Use parentheses when you substitute, especially with negative numbers. It will save you from so many common mistakes. Trust me on this one. Okay, next up, we just follow the good old order of operations, PEMDAS. Multiplication comes before addition and subtraction. So, 2 times negative 1 gives us negative 2, and 3 times 4 gives us 12. Simple as that.
And now for the final step. We just clean it up by adding and subtracting from left to right. So negative 2 plus 12 gets us to 10. Then 10 minus 1 leaves us with our final answer, 9. And that's it! We did it! We turned that whole expression into one simple number.
So there you have it. We've gone from vocabulary to combining terms all the way to finding a final value. You now have the fundamental tools to work with algebraic expressions. And this stuff isn't just for a math test. It's the bedrock for things like calculating a budget, figuring out a rocket's trajectory, or even coding a video game. So the real question is, what problems will you use it to solve?